Go? Okay. Okay, we're gonna talk about polynomials today. Raise your hand if you ever heard of a polynomial before. Let the record show 3 or 4 people have their hands kind of up. What is it? No idea. No, we don't. We have no idea. All right. All right. All right. Well, polynomials are just a bunch of terms added together. And what are terms? So I want to break this down for you in a couple of ways here, okay? Just like there are lots of cars out there are lots of different cars. We have just different names for them, right? Some are Fords, some are Hondas, whatever. There's lots of different cars, but they all do the same kind of thing. Well, polynomials for us, they kind of fit into a couple of different categories, okay? So I'm going to tell you the different types of polynomials that we do have, so that we know that we have. We have something that are called monomials. Ooh, whoa, hold on. You guys know exactly what you're talking about. We have something called binomials. And then we have something called trinomials, yeah. Okay. And then we have this category that's called other. So sure, that can work for that, yeah. Cool. Okay, I want to discuss each of these sort of categories, okay? Remember, each of these, monomials, binomials, trinomials, and other, okay, they all are together. They are all polynomials. Even though they look differently, they all represent polynomials. So let's first start off talking about monomials. Do you see a word in there that might give something a mono, right? So mon means one. Very good. So, yeah, you guys got it. Monomials have one term. They have one term. And let me give you an example of a monomial. 3x. That's an example of a monomial. Now, is a monomial also a polynomial? Yes, it sure is. It's a certain type, right? Just like a Honda is a certain type of car, right? Or a Nike is a certain type of shoe. It's a brand. It fits in there. So monomials are types of polynomials. Here's an example, 3x, okay? Let me give you another example. The number 5. The number 5 could also be considered a monomial. All right? Yeah. Can you guys make one up? Make up your own monomial right now. What would it be? 1y. 1y. Good. Give me another one. 2y. Okay. Now, not division, right? We're not talking about division here. We're talking about just a single term being multiplied together. A single term being multiplied together. What about a binomial? That means 2. So the binomials have to have 2 terms. You got it. Almost. You're almost there. 2 terms. Let me give you an example. Okay, I'll give you an example of mine. 3x plus 1. 3x plus 1. 2 individual terms. So let me highlight those terms for you. The first term is 3x, and the second term is 1. Collectively, together, they make up a binomial because there's 2 terms. You guys get it so far? Okay. Notice that they are 2 monomials being added together, right? A 3x and a 1 being added together. I could have also said this. 5x minus 3. That's also a binomial because it has 2 terms. What's the first term in there? 5x. What's the second term? 3. And what am I doing in between them? Subtracting. As long as I'm adding or subtracting, then I'm good to go. Right? I can't be multiplying or dividing in this case. All right. Can you guys make up another binomial on your own? What would it be? 5x plus 2. There you go. Way to stray out too far from the curve, right? 5x plus 1. Okay, good. Sounds like you guys are getting it pretty good here. All right, let's talk about a trinomial. Can you follow the pattern? If a monomial has 1 term and a binomial has 2 terms, then what's a trinomial? It has 3 terms. Yeah, 3 terms. There you go. Because of the word tri, it has 3 terms. So let me give you an example of a trinomial. Could be like this. X squared plus 2x plus 1. That is an example of a trinomial. And a trinomial, again, is just a type of polynomial. So this is what we call a trinomial here. It's got 3 terms. The first term is x squared. The second term is 2x, and the third term is a 1. Does that make sense so far? Yes. Okay. Can you guys make up a trinomial for me? X, okay. Okay, this brings up a good point. X plus x. How much is that? That's just 2x. X plus x is 2x. That's just a monomial. So we need to do something. So the exponents mean something. So how about x squared plus x minus 5? That right there, that's a trinomial. So I want you to understand the idea of terms. And then we have this thing called other. Anything that's greater than 3 terms. We're just going to call that other for now. All right? So what I want you to take away from this first box is polynomials are a collection of terms using addition or subtraction. A collection of monomials, really. And there are 3 different types that we're going to talk about in this classroom. We're going to talk about monomials. They have 1 term. Binomials. They have 2 terms. Yeah, that'd be cool. All right, for the next part, where we're going here, binomials and trinomials and monomials, I want to talk about the parts of a polynomial. So there's lots of words here today, and so today is an introduction of what all these new vocab words are, because we have to learn how to speak the language of polynomials, right? So I have two different terms set up, right? So first of all, let's do this. Let's circle this whole thing. You guys tell me, what type of a polynomial is this? This is a monomial. Good. How do you know it's a monomial? It's a monomial. There's only 1 term, right? How many terms does it have? 1. I just said that. Yeah, good. Okay, good. Now let's talk about these parts here, okay? This part here, the x, what do we call that part? That's called the variable. Very good. That's called the variable. Right? What's the 4 called here? Yeah, you guys you guys know that as exponent, right? But when we're talking about polynomials, another term that comes into play called the degree. The degree. So the degree is the same as the exponent for monomials here. So this is a 4th degree monomial. So we can identify what type of polynomial this is by A, either the number of terms it has, which in this case is 1, and B, the exponent or the degree. Okay, so we have the variable, we have the degree, and then we have this part in the front here. This number 3 here. That number 3 is called the coefficient. So the coefficient is the number in front of the variable. So the whole thing together makes up a monomial. It's got 1 term. It has a variable, has a coefficient, and it has an exponent or a degree is the word that we're calling that. Yeah, so far so good? So far so good. Okay, now let's take a look at this one over here. Okay? You tell me, what type of a polynomial is it? This is a trinomial. Very good. How do you know it's a trinomial? It's a trinomial. It has 3 terms. Very good. It has 3 terms. Can you name the terms really quickly? What are they? 2x squared, 6x, and a 1. Those are all 3 of the terms. Okay, great. Now, let's talk about the variable. Are all the variables the same here so far? Yeah, the variable is x in this case, correct? So there's my variable. But now, here's the problem. The 2, what does that represent? The degrees, right? What's the exponent on the x here? This is a 1. Very good. And what's the exponent on the 1? No, it can't be the same. This is like this. This is like x to the 0. Is that correct? Because anything to the 0 power is 1. So 1 times 1 is still 1. So now check it out. We have a degree of 2. We have a degree of 1 and a degree of 0. So the question is what's the degree of the whole trinomial? Is it the 2, the 1, or the 0? It's the 2. Turns out you take the biggest one. So this whole trinomial, this whole thing has a degree of 2. So this is a 2nd degree trinomial. So we take the biggest one that we see. We take the biggest one that we see. Now let's talk about the coefficients. I have a 2, I have a 6, and I have a 1. A 2, a 6, and a 1. Which one is the leading coefficient? No, that's what you'd think. It's not. It's the one that's attached to the highest degree. So the 2. So the 2 is what we call the leading coefficient. All right. And I know this is a lot. There's a lot of words here, but introducing them to, we're going to use them over and over again. So let's review. So we have the coefficient, the number in front of the variable. We have the variable, and we have the degree. The degree of a monomial is just the highest one that you see, or the sum of all the variables, but there's only one there. And then in the degree of our trinomial is the highest one that we see. No, in this case, that was a 2. Yeah, you got it. I've written down. Yeah, you're right. You're totally right. So one thing that we're going to do with polynomials is we're going to have to add or subtract them. All right? And in this case, I have two different polynomials, okay? I have this first polynomial here, and how could you classify that polynomial? Is it a monomial, a binomial, a trinomial, or other? Binomial. That's a binomial. There's two terms there. Good. Okay. How could you classify this one over here? There's no word as a quadnomial. We just call it other, right? Just call it other for right now. Okay. So I have a binomial, and I'm adding it to a fourth degree polynomial. Okay. What is the degree of our first polynomial here? 4. Very good. What's the degree of our second polynomial here? 4. So they're both fourth degree polynomials. Okay. Now, the question is, how do we add these together? How do we add or subtract polynomials? There's something that you've heard before. What do you think to do?
You can only add of the same degree.
Okay, so you can only add, I think what you guys are trying to say is only add like terms. Okay, so have you heard the phrase before, like terms? Something that are like terms? Yes, you've heard the term like terms. It means two things. Two things have to happen to be like terms. What are the two things that has to happen? They have to have the same exponent, very good, or same degree, plus the same variable. That's what it means to be like terms. You have to have these two things together. Must both be true in order to be a like term. So you have to have the same degree and you have to have the same variable. Okay, here's what we're going to do. We are going to circle all the ones that have the same degree. So I see a 3x to the 4th. You guys see that? And I see a 6x to the 4th. Are those like terms? Why do you say no? Do they have the same exponents, 4 and 4? Do they have the same variable, x and x? So are they like terms? Yes, they are. So let's ask ourselves, if I have 3x to the 4th here and 6x to the 4th there, how many grand total x to the 4th are there? 6x to the 4th plus 3x to the 4th. All I do is add their coefficients. 6 and 3 is how much? 9. So this is going to be a grand total of 9x to the 4th. So I've done this one, and I've done that one. I like to cross them off as I go. All right, I like to work down from the highest degree exponent. So if I just did the 4th degree, what's the next one in line down? 3rd degree. I only see one term that has a 3rd degree. So you just leave it just like that. You got 3x to the 3rd. You got it. Okay, next. I've done the 4s. I've done the 3rd degrees. What's the next lowest degree? A 2. So I see a positive 2x squared and a negative 3x squared. So I'm going to add their coefficients. I'm going to add 2 plus negative 3. How much would that be? That would be negative 1x squared. It's negative 1x squared. You guys good with that? And then finally, what's the last thing I have? I have a 4, don't I? Plus a 4. And now I'm done. That's pretty easy, right? Okay, do you notice something about this, though? Let me show you something. Do you notice that it goes 4, 3, 2, and then 1? Very good, because you can write this as x to the x, or 4, 3, 2. Actually, this is just 0, huh? X to the 0. Okay, they don't have to be. It doesn't have to be 1. But do you notice that they are going in order down left to right? You know what that's called? That's called standard form. So a great question would be, what is standard form over here? Yeah, define what is standard form. That's a great question. define what is standard form. Okay. Okay, let's do another example together. Let's do B. All right. I have 5x to the 5th plus 3x squared plus 2. So what type of a polynomial is this? That's a trinomial. Very good. What type of polynomial is this? We call that other for now. It has 4 terms in it, right? What's the degree of my trinomial? 5. Very good. What's the degree of my other term here? 5. Good. What's the leading coefficient in my first polynomial? What's the leading coefficient in my second polynomial? 7. Very good. Okay, so what we're going to do is we're going to subtract these. Notice that there's a subtraction sign. With the subtraction sign, you always have to take the warning. And the warning is that that subtraction sign must be distributed to each term after the sign. That's a big warning. Warning. Figure out what that warning is. We have to distribute that sign. The most common error that students make is they forget to distribute that sign. Okay, so I'm going to start with the highest degree term, which would be a 5. I'm going to circle a 5x to the 5th minus a 7x to the 5th. Okay, what's 5x to the 5th minus 7x to the 5th? Negative 2x to the 5th. That is correct. And I've taken care of that one, and I've taken care of that one. What's the next highest degree term going down? X to the second power, is that correct? Okay, so I have 3x to the second power here minus 4x to the second power there. So 3x squared minus 4x squared. How much is that? Negative 1x squared. You can write the 1 if you want, but you don't have to. So I did that one. Good. What's the next degree going down? 1. Do you see any x terms by themselves? Look harder, look harder. What do you see? How about this one over here, this 3x? But do I write down positive 3x or negative 3x? I have to write down a negative 3x because remember, I need to distribute that sign. So negative 3x. Good. Took care of that one. Yes. And then finally, I have my last terms. I have a 2 minus a negative 4. Negative, 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 positive. So 2 minus negative 4 is a positive what? Positive 6. Good. And now I have written it in, what's the form called again? There you go. Okay. Here is the first one. The first expression is negative 6. Okay, ladies and gentlemen, do you think that this is a polynomial? Yes or no? Yes, you would be correct. It is a polynomial. Yes. What's the degree of this? The degree is 0, and how many terms does it have? And it has 1 term, so we call that a monomial. What do you think about that? Yeah. So we'll do degree, and then terms, and then the name, if there is a name. Okay. So it has the degree is 0, that has to 1 term, and it's monomial. Okay. Here's the next expression, and that expression is this: m to the negative 3 plus 4. What do you guys think? Yes or no? Yes. One person says yes? Yes. Well, it turns out the answer is no. This is not a polynomial. And the reason it's not a polynomial is why. Anybody have any guesses? Yeah, what do you think? Yeah, can't have a negative exponent. You got it. Can't have a negative exponent. So we don't have to worry about it because that's not a polynomial. What about this one? About negative x squared plus 4x to the 3rd. Is that a polynomial? Yes. Yes, it is. This is a polynomial, right? What's the degree? What's that? 3. How many terms does it have? 2. So, a binomial. Very good. We call that a 3rd degree binomial. All right, next one is 9 minus 5x to the 4th plus 3x. What do you think? Is that a polynomial? Yes, that is a polynomial. What's the degree? 4th degree. How many terms? Has 3 terms. What do we call that? Trinomial. All right, and then last one here. How about 2x to the third plus 4 to the power of x? What do you think? Yes or no? Is that a polynomial, yes or no? No, it's not a polynomial. Why is it not a polynomial? That's right. Exponent or degree can't be a variable.